this journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathemati Yan. I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different concepts and skills in Mathematics 9. In today's episode, we are going to solve quadratic equations that are not written in standard form. And so while we learn something new, we will recall two things at the same time. One, how to write a quadratic equation in standard form. Two, the four methods in solving quadratic equations, namely extracting square roots, factoring, completing the square, and using the quadratic formula. Whoa, I hope I didn't sound as if we have so much to do today. But nonetheless, let's get started, Kagamat. Our first task is to rewrite these equations in standard form. Remember that a quadratic equation in standard form, if it is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Equation number 1, x multiplied by the binomial x plus 4 equals -3. First, we multiply the quantities on the left side of the equation. We apply distributive property. X times x is x squared. X times positive 4 is positive 4x. So the equation becomes x squared plus 4x equals -3. Next, we increase both sides by 3 so that the left side contains all the terms of the quadratic equation and the right side is just 0. Hence, the standard form of the equation is x squared plus 4x plus 3 equals 0. And there, equation number 1 is done. Equation number 2, 5x squared minus 12 equals 2x squared plus 3. Here, we have nothing to multiply, so what do we do then? We must decrease both sides by 2x squared and by 3. We may arrange the terms in descending powers so that similar terms are beside each other, and it's going to look like this. Then we combine similar terms to simplify both sides. So we have 5x squared minus 2x squared equals 3x squared, and -12 minus 3 equals -15. Hence, the left side can be written now as 3x squared minus 15, while the right side is just 0, since 2x squared minus 2x squared is just 0, and positive 3 minus 3 is also equal to 0. And thus, the standard form of the equation, 5x squared minus 12 equals 2x squared plus 3, is 3x squared minus 15 equals 0. Let's record this in the table. Equation number 3, x plus 1 quantity squared plus x minus 2 quantity squared equals 10. Here, we have to expand the binomials on the left side by squaring each as indicated by the exponent 2. We have x plus 1 quantity squared equals x squared plus 2x plus 1. X minus 2 quantity squared equals x squared minus 4x plus 4. Then we add the results as indicated by the plus sign in equation number 3. Of course, we only combine similar terms. X squared plus x squared equals 2x squared. 2x plus -4x equals -2x. And 1 plus 4 is equal to 5. Hence, the left side of the equation is now simplified as 2x squared minus 2x plus 5. Now, we decrease both sides by 10. Then we combine the constants. Thus, the standard form of the equation is 2x squared minus 2x minus 5 equals 0. We record this in the table. Now that we are done writing the equations in standard form, we have to solve each quadratic equation using the most convenient methods. Let's do this. Equation number 1. X squared plus 4x plus 3 equals 0. Since the value of the coefficients b and c in the equation are not 0, we may solve it by factoring. Notice that the leading coefficient or the numerical coefficient in the quadratic term x squared is the invisible one. This means that the factored form of the trinomial must look like this. The first terms of the binomial factors are both x, since the square root of x squared is x. Now, we have to think of the values of the constants m and n. We take note of the following. The product of m and n must be equal to the constant term in the equation, which is 3 in this case. The sum of m and n must be equal to the numerical coefficient of the middle or linear term, which is 4 in the given equation. Since their product and sum are both positive, the two numbers must also be both positive. Have you figured them out? The two numbers are 3 and 1. 3 times 1 equals 3, and 3 plus 1 equals 4. We can position these now as the constant terms in the binomial factors. Since their first terms in the binomial factors are identical, we can place each in either binomial. Hence, the factors of x squared plus 4x plus 3 are x plus 3 and x plus 1. We can now rewrite the equation as binomial x plus 3 multiplied by binomial x plus 1 equals 0. Indeed, we can solve the given equation by factoring. Then we apply zero product property. We equate each factor to 0. Hence, the equations x plus 3 equals 0 and x plus 1 equals 0. Then, we solve for x in each equation. In the equation x plus 3 equals 0, x must be equal to negative 3 after we decrease both sides by 3. In the equation x plus 1 equals 0, x must be equal to negative 1 after we diminish both sides by 1. So, the roots of the equation are negative 3 and negative 1. Let's record this in the table. Now let us check if these roots are correct by using a different method to solve the equation. While not all quadratic equations can be solved by factoring, every quadratic equation can be solved by completing the square and by using the quadratic formula. Alright then, let's solve the equation x squared plus 4x plus 3 equals 0 again. As I have just mentioned, we have two methods to choose from: completing the square and using quadratic formula. Allow me to use completing the square. We isolate the terms with the variable. In this case, we decrease both sides by 3. Hence the equation x squared plus 4x equals negative 3. Since the leading coefficient is already 1, no need to divide both sides of the equation by the value of a. Next, we take the numerical coefficient in the linear term. The linear term is 4x and the numerical coefficient is 4. We square its half and add the result, which is 4, to both sides of the equation. The equation now contains a perfect square trinomial, which is x squared plus 4x plus 4 and is equal to 1. We express the perfect square trinomial x squared plus 4x plus 4 that is on the left side of the equation as a square of a binomial. We begin with getting the square root of x squared, which is x. So, the first term of the binomial is x. Next, we get the square root of 4. Its principal root is 2. So, the constant term in the binomial should contain 2. And then, we copy the sign of the middle term in the perfect square trinomial. Hence, the constant term in the binomial is positive 2. X squared plus 4x plus 4 is equal to to the square of the binomial x plus 2. Therefore, we have the equation x plus 2 quantity squared equals 1. At this point, the equation is of the form a multiplied by the square of x minus h equals k, where a is just 1, or of the form x minus h quantity squared equals k, and can be solved by extracting square roots. And upon extracting square roots of both sides, we get x plus 2 equals positive or negative 1. We split the equation into two. We have x plus 2 equals 1 and x plus 2 equals negative 1. We isolate the variable x in each equation by decreasing both sides by 2. In the first equation, the value of x is negative 1. In the second one, the value of x is negative 3. Hence, by completing the square, we have determined that the roots of the equation are negative 1 and negative 3. Let's record these results in the table. And you see, the methods used are different, but the results are the same. Let's solve the second equation. 3x squared minus 15 equals 0. Since it has no linear term, or the value of b is 0, it can be rewritten in the form ax squared equals k, and hence can be solved by extracting square roots. So we increase both sides of the equation by 15, and this results to the equation 3x squared equals 15. Before we extract the square root of both sides, we must divide them by 3, since the numerical coefficient in the quadratic term is 3 and not 1. The equation now becomes x squared equals 5. And upon extracting square root of both sides, we get x equals positive or negative square root of 5. 5 remains under the radical sign since it's not a perfect square and its only perfect square factor is 1. Therefore, the roots of the equation are square root of 5 and negative square root of 5, or simply written as positive or negative square root of 5. Let's record the results in the table. To check whether the obtained roots for equation number 2 are correct, let's solve the equation again, but this time by using quadratic formula. Let me emphasize that every quadratic equation can be solved by either completing the square or using the quadratic formula. And since we used the completing the square method a while ago, I opted to use the quadratic formula this time. In the equation 3x squared minus 15 equals 0, the values of the coefficients are as follows. A is 3, b is 0, and c is negative 15. We substitute these values in the quadratic formula. So we have x equals the negative of 0 plus or minus the square root of the quantity 0 squared decreased by the product of 4, 3, and negative 15 all over 2 times 3. We simplify. Negative 0 is just 0 and can be omitted already. 0 squared is 0 and can also be omitted. Negative 4 times 3 times negative 15 is equals 180. So x equals positive or negative square root of 180 all over 6. 180 is not perfect square, but it has perfect square factors aside from 1, the highest of which is 36. So we can simplify the radical square root of 180 if we express 180 as the product of 36 and 5. We take out the principal root of 36, which is 6, and retain 5 under the radical sign. Hence, square root of 180 can be simplified as 6 square root of 5. This results to the equation x equals positive or negative 6 square root of 5 over 6. we simplify the value of x by dividing both the numerator and the denominator by 6, and thus x equals positive or negative square root of 5. Let's record the results in the table. And we can clearly see that both methods used to solve equation number 2 yielded the same result. Let's solve equation number 3. 2x squared minus 2x minus 5 equals 0. Can this be solved by factoring? We can use its discriminant to find out. Recall that the discriminant d is equal to the value of b squared minus 4ac. In the equation, a is 2, b is negative 2, and c is negative 5. Thus, the discriminant of the equation must be equal to negative 2 quantity squared minus 4 times 2 times negative 5. Performing the operations indicated, we should get that negative 2 quantity squared is equal to 4. And 4 times 2 times negative 5 is equal to negative 40. So, d must be equal to 4 minus negative 40, or can be written as 4 plus 40, and thus d is equal to 44. The discriminant of the equation is 44, which is not perfect square. Only those quadratic equations whose discriminant is either 0 or perfect square can be solved by factoring. And since the discriminant of the equation has been already identified, we might as well use the quadratic formula to solve the equation. Recall that the value of the discriminant appears under the radical sign in the formula. So by substitution, x is equal to the negative of negative 2 plus or minus the square root of 44 all over 2 times 2. Negative of negative 2 is positive 2. Square root of 44 can be simplified as 2 square root of 11. 4 is the largest perfect square factor of 44, and 44 equals 4 times 11. The square root of 4, which is 2, is taken out as the coefficient of the radical square root of 11. 2 times 2 is just 4. So, x must be equal to 2 plus or minus 2 square root of 11 all over 4. The constant 2, the coefficient of the radical, which is also 2, and the denominator 4 are all divisible by 2. It means we can divide both the numerator and the denominator by 2. And the resulting equation is x equals 1 plus or minus square root of 11 all over 2. And this equation already displays the two unequal real and irrational roots of the equation. Let's record this in the table. We only have one option to check whether the obtained roots for equation number 3, 2x squared minus 2x minus 5 equals 0, are correct, and this is by completing the square. We isolate the terms with a variable, so we increase both sides by 5. The equation becomes 2x squared minus 2x equals 5. We divide both sides of the equation by 2 since the leading coefficient of the equation is 2. The resulting equation is x squared minus x equals 5 over 2. We take the numerical coefficient in the linear term, which is negative 1 in this case, square its half, and add the result, which is 1/4, to both sides of the equation. The left side should be expressed as the square of a binomial. So we begin with getting the square root of x squared, which is x. So the first term of the binomial is x. Next, we get the square root of 1/4. Its principal root is 1/2. So the constant term in the binomial should contain 1/2. And then we copy the sign of the middle term in the perfect square trinomial. Hence, the constant term in the binomial is negative 1/2. So we have x squared minus x plus 1/4 equals the square of the binomial x minus 1/2. On the right side, 5/2 plus 1/4 must be equal to 10/4 plus 1/4, which is equal to 11/4. Hence, we have the equation x minus 1/2 quantity squared equals 11 over 4. By extracting square roots, we must get that x minus 1/2 is equal to positive or negative square root of 11 over 2. We may isolate x now to determine the expression equal to it. So, we increase both sides of the equation by 1/2, arranging the quantities on the right side so that the plus or minus sign separates them. We get that x equals 1/2 plus or minus square root of 11 over 2, which can be expressed as 1 plus or minus the square root of 11 all over 2, since the two quantities have the same denominator. Let's record this in the table. And again, the roots obtained using the two methods are just the same. Kagamath, ready your pen and your paper. This is Math the Moment. We have to write each equation in standard form and identify its roots. Let's do this. Equation number 1, quantity x minus 6 squared equals 2x minus 5. For 45 seconds, go! Time is up. Expanding the binomial on the left side by squaring it, we have x minus 6 quantity squared equals x squared minus 12x plus 36. So the equation becomes x squared minus 12x plus 36 equals 2x minus 5. Then we have to set the right side equal to 0. So we have to diminish both sides by 2x and increase both sides by 5. We combine similar terms. Negative 12x minus 2x is negative 14x. 36 plus 5 is equal to 41. Arranging the terms in descending powers, the left side is simplified as x squared minus 14x plus 41, while the right side becomes 0. And there, the equation is already in standard form. The trinomial is not factorable since 41 has no factors whose sum is negative 14. Let's solve the equation by completing the square. This is my choice. You might have preferred the quadratic formula over this method. First, we isolate the terms with variable by decreasing both sides by 41. Hence, the equation becomes x squared minus 14x equals negative 41. The numerical coefficient of x squared is already 1, so we must determine now by what quantity should both sides of the equation be increased by to complete the square. We square the half of the coefficient of x, which is negative 14 in this case. Then, we add the result, which is 49, to both sides of the equation. The left side contains a perfect square trinomial that can be expressed as the square of the binomial x minus 7, while the right side can be simplified as 8. Thus, the equation x minus 7 quantity squared equals 8. We now extract the square root of both sides and we get x minus 7 equals positive or negative square root of 8. 8 has 4 as its largest perfect square factor, so square root of 8 can also be expressed as the square root of 4 times 2, and thus can be simplified as 2 square root of 2. Therefore, x minus 7 must be equal to positive or negative 2 square root of 2. And lastly, by increasing both sides of the equation by 7, x is equal to 7 plus or minus 2 square root of 2. Equation number 1 solved. equation number 2, we have the binomial a plus 1, quantity squared, plus the quantity a minus 8 squared equals 50. Let's write it in standard form and solve it in 45 seconds. Let's go! Time is up. A plus 1 quantity squared must be equal to a squared plus 2a plus 1, while a minus 8 quantity squared must be equal to a squared minus 16a plus 64. Now, let's add the results by combining similar terms. A squared plus a squared equals 2a squared. 2a plus negative 16a equals negative 14a. 1 plus 64 equals 65. Therefore, the left side of the equation number 2 can be simplified as 2a squared minus 14a plus 65. Then, we diminish both sides by 50 to set the right side equal to 0. So, the standard form of the equation number 2 is the equation 2a squared minus 14a plus 15 equals 0. The discriminant of this polynomial, 2a squared minus 14a plus 15, is given by the expression negative 14 quantity squared minus 4 times 2 times 15, which must be equivalent to 196 minus 120. Thus, the discriminant is equal to 76, positive, but not perfect square. This means that the trinomial is not factorable. So we might as well solve the equation using the quadratic formula. So x equals the negative of negative 14 plus or minus the square root of the discriminant 76 all over 2 times 2. Simplifying the radical part, x must be equal to positive 14 plus or minus the square root of the product of 4 and 19 all over 4. So x must now be equal to 14 plus or minus 2 square root of 19 all over 4. The constant 14, the coefficient 2, and the constant 4 are all divisible by 2. So we can reduce the expression to its lowest term by dividing both the numerator and the denominator by 2. Thus, the roots of the equation is denoted by the expression 7 plus minus the square root of 19 all over 2. And that's it, Kagamath. I hope today's episode has been very helpful. And before we go off air, let me share a motto I hold into as a mathematics teacher and learner at the same time. Math means mistakes allow thinking to happen. See you again as we face, overcome, and befriend the challenges. We can because we are Mathematics yan.